Okay then, cloud gurus, are we ready for a demo? Alright, then here's the plan. We'll throw a deployment out there and front it with a service. It'll be a web server based on a custom image so that every time you hit it, it does a computationally intensive calculation. Clever stuff. Well, we'll lash that up to a horizontal pod autoscaler that says crank up the number of replicas whenever pods are using more than half of the CPU they've requested. Now, we'll see the detail in a minute, but it's a web server with one replica hooked up to an HPA. Then we'll fire up a load generator and we'll start hitting it. And as we're doing that, it's going to ramp up on CPU, meaning before long it'll breach the limit in the HPA and we'll see the magic happen. More replicas, yeah? And that's the plan. Now, I'm going to be running on a cluster with auto scaling enabled. So, behind the scenes, we'll probably see some new nodes getting spun up. And if we do, we'll take a look at it. But that's a side issue for now, right? We've got a whole demo on that coming later. For now, the focus is on the pod scaling. Now then, the demo's loosely based on this walkthrough here. I've just tweaked it a bit to make it more declarative. So, this right here is our declarative config file. I've lumped everything we need into a single file, but you don't have to, right? Each object can be in its own file if you like. I've just gone with a single file so that I can deploy it all with one command. Now, if you're doing it like this in a single file, you separate each object with 3 dashes like these. Anyway, we're defining a namespace. Now, it's good practice to use namespaces, but don't think of them as strong security boundaries, because they're not. Like, you might be fine with them for isolating environments like dev, test, and QA or whatever, but they are not for isolating business units or customers. For that, you're going to want separate clusters. Anyway, we've got a service object here, kind of just as a reminder really. I mean, it's not strictly needed, but I figured we're far enough through the course now to be seeing how things can fit together. Well, it's in the ACG namespace, and it is a load balancer type, so it'll spin up a load balancer on your underlying cloud. And then it's going to balance traffic over pods with this label. Brilliant. Well, we've got a deployment. We are starting out with one replica, and then the pod's got a single container based on this image here. Now, this is the image from the example on the Kubernetes website that I mentioned. And it's basically a really simple web server that performs a moderately intensive calculation each time it's hit. The big idea being, if we hit it a lot, it'll stress CPU and breach this request down here. Which, if we've been taking notes, says, give me 20% of a CPU, please. So far we've got a namespace, a service, and a deployment defining a single pod. And we know that if we hit the pod hard enough, it'll crack. Meaning, if we've got an HPA object, we should be able to see some scaling action. Well, speak of the devil, horizontal pod autoscaler. It's in the ACG namespace, linked to a deployment called ACG Web, which is what ours is named here. We're saying keep it between 1 and 10 replicas, which is arbitrary, yeah. It could be 100 if you wanted, yeah. But last but not least, we're saying keep pod CPU utilization below 50% of what was requested. Now remember, we're requesting 20% of a CPU, and half of that, that's 10%, yeah? So if any pods that the HPA here's watching breach 10% of a CPU, scaly time. Looking good, yeah? Well, let's deploy it. Alright, now then, some of the things we're going to be doing will take a minute or two to come up, like the load balancer, and maybe images take a minute or so to pull. So from this point on, I'm going to start editing the video so that it flows smoothly. But you know what? It might make things a bit quicker than normal. So if you're watching it and thinking, wow, this feels unrealistically fast, it's just because I've edited the video. Well, let's see the state of that deployment. Okay, we called it ACG Web, we asked for one, and we've got one. What about the HPA? Okay, looking good as well. A name. Oh, hang on. Give things a chance to settle here. Okay, a name, targeting our deployment. The metrics here is 50% of a CPU, and right now it's doing absolutely nothing. Then we've got min pods, max pods, and right now just the one replica. Cool. And being a bit cheeky, right? Yeah, just the one node in the cluster. And this is GKE, right? So this is listing workers. The control plane stuff's hidden. Anyway, I'm going to fire up another terminal here. And okay, fair enough, I'm breaking my own rules here. I am imperatively firing up a load gen pod. Ugh, never mind though. And this while loop here is going to hammer the web server pod. Now then, the address here is the internal address of the service we created. So the name of the service here, the name of the namespace that it's in, and then the rest's default. And I guess actually, because it's a load balancer one that we defined, we probably could hit it from the internet as well. But you know what? This'll do for us. Okay, away that goes, causing some stress. So if we check our HPA object again here, there we go. Lots of stress, but just still the one replica. So how about we stick a watch on that? Okay, replica count going up. Stress, yeah? We stress the CPU over the target at 50%, we get more pods. If we look at our deployment, that's on the move as well. And this is expected, yeah. The HPA woke up, noticed that the pods were being overstressed, so it told the deployment to make some more, and that's what's happening. Now, we said that the HPA doesn't have a clue how to scale or schedule pods. It just knows when to do it. For the how, it asks the deployment to take care of it. So if we dump the deployment YAML... Now, this is the deployment record on the cluster. You'll see it's got a status section here, which is the current observed state. But under the spec section, where we see the desired state, if we can find spec.replicas, there we go, 4. And that's how it works, because back here in VS Code, yeah? Right, we're just asking for 1, and that's what we posted to the cluster. But the HPA's reacted to load, and it's dynamically updated the record asking for 4. Well, that updates desired state, watch loops notice, and the control plane kicks in to reconcile. And for me, it's a work of art. Now, you know what, being cheeky again. Yeah, more nodes. So demand went up and we scaled up pod count. But at some point the cluster said, nah, back off a second guys, I am out of space. And any new pods that were being scheduled went pending. In fact, that'll be when we saw the deployment at only 3 out of 4. Not sure if you noticed that. Anyway, the cluster autoscaler noticed and it spun up new nodes. But you know what, I'm jumping ahead, cluster autoscaler's next. In summary for here, we deployed a single replica of a web server pod. We did things the proper way, and we said that each one of them should get 20% of a CPU. Then we created an HPA object to watch that deployment, with a rule that said if any of the pods in the deployment use more than half of their requested CPU, spin up some more pods. We deployed it all, stressed the pods, and guess what? We got more pods spinning up. Have some of that. And if we let things cool down, you know what? We'll see replica count drop, nodes start to terminate, all that kind of stuff, right? And if that's not beautiful, I don't know what is. Anyway, we're not done yet. Time to get under the hood a bit with scaling nodes.